Let's work with the factor theorem. For example, let's determine whether x minus 3 is a factor of p of x. And we can use the factor theorem to help us out here. And the factor theorem states that a polynomial p has a factor x minus r if and only if r is a zero or a root of that polynomial. So we want to use this to determine whether x minus 3 is a factor of this polynomial here. So our r here is 3, and we want to compute p of 3 by plugging in 3 wherever we see an x and see if we get 0 as our answer. And if we do, then yes, x minus 3 will be a factor of p. All right, so what is p of 3? This is equal to 2 times 3 cubed minus 5 times 3 squared minus 3 minus 6, which is equal to 2 times 27 minus 5 times 9 minus 3 minus 6, or 54 minus 45 minus 3 minus 6. And 54 minus 45 is 9, and then minus 3 minus 6 is negative 9. So sure enough, yes, this is equal to 0. So since p of 3 is equal to 0, x minus 3 is a factor of p. Let's see another example. Let's determine whether x plus 2 is a factor of p. Again, we'll use the factor theorem, which states that x minus r will be a factor if r is a zero of p. We want to determine whether x plus 2 is a factor of p of x. But what is our r here? X plus 2 is really x minus a minus 2. So be careful here, our r is negative 2. So we'll plug in negative 2 everywhere we see an x here, and if we get 0 as an answer, then yes, x plus 2 will be a factor of p. So what is p of negative 2? This is equal to negative 2 times negative 2 to the 4th minus 2 times negative 2 cubed plus 6 times negative 2 squared minus 5. Which is equal to negative 2 times 16, and then minus 2 times minus 8, and then plus 6 times 4 minus 5, which is equal to negative 32 plus 16 plus 24 minus 5. Now 16 plus 24 is 40, and 40 minus 5 is 35, so this is minus 32 plus 35, which is equal to 3, which is not 0. So since p of negative 2 is not equal to 0, x plus 2 is not a factor of p. And this is how we work with the factor theorem. Thank you, and we'll see you next time.